So let's talk about one of the most elegant problems in the heliocentric model. And I'm going to walk through it step by step, because once you see it, you're gonna have to admit that you see what I see. And we'll start with this observation. The sun travels through the zodiac every year, but there's a 20-minute difference between the solar year and the sidereal year. That 20-minute gap accumulates. So after 72 years, it adds up to exactly 1 degree of separation between the sky you're looking at now and the sky you would see on this exact date and time 72 years from now. After 25,920 years, the great year, you've cycled through all 360 degrees of the zodiac. That's called the precession of the equinox. It happens in both models. It's just an observation. Now, it does get interesting where on a flat plane, that 20-minute annual gap is exactly what it looks like, a slow accumulation that shifts what stars you see over thousands of years. Simple, observable, no additional mechanism required because it's just a difference in speed between the sun and the stars. But the heliocentric model has a big problem. If the Earth is orbiting the sun and that orbit is sliding by 20 minutes every year, after 13,000 years, you're on the opposite side of orbit from where you started, 180 degrees away. That means what stars you see at night depends entirely on your orbital position, because at night the sun is directly below your feet and the stars are above your head. And the stars above your head are determined by where you are in the orbit. The zodiac literally circles the orbital path. It has nothing to do with which direction you're pointing. It's about where you are. So after 13,000 years, you're 180 degrees away in orbit. You should be seeing completely different stars. And you should be experiencing opposite seasons. Because the Earth is always tilted in one direction in space, and your angle to the sun at each orbital position is what creates the seasons. Summer, winter, spring, fall, all based on the Earth's angle and the angle the sun's rays hit the Earth. Now, the seasons don't shift. The summer solstice stays the summer solstice. The equinoxes stay on the calendar. So how does a heliocentric model explain this? They inserted the wobble. What's the wobble? They claim the Earth wobbles like a spinning top, a slow gyroscopic precession of the 23.5 degree axial tilt that rotates that tilt in a full circle over 25,920 years. So as the Earth slides to a different orbital position, the wobble keeps the angle of the Earth's tilt pointed in the right direction relative to the sun, keeping summer as summer and winter as winter, regardless of where you are in the orbit. And I want to be fair here. On the globe model, you do need something like this. Without it, the seasons would drift catastrophically. Over 1,000 years, you'd be in a different season. But my problem is the wobble has to match the precession rate exactly. Not approximately, exactly. Because if the wobble rate and the precession rate diverge by even a fraction, the seasons will start drifting. The only reason the summer solstice stays the summer solstice is because those two rates are perfectly synchronized. How ironic. And I'm actually going to show you the math. The precession of the equinoxes is 360 degrees divided by 25,920 years, which equals 0.0138 degrees per year. Divided by 365.25 days, that's 0.00038 whatever degrees per day. And the 20-minute annual discrepancy comes from the difference between the sidereal day and the solar day. So 3 minutes and 56 seconds, that's 3.93 minutes divided by 1,440 minutes per day, which equals 0.00272917% of the day. So if you multiply by 360 days declination, you get 0.985 of a revolution versus one full revolution. The difference is 0.015 multiplied by 1,440 minutes, And you get approximately 21.6 minutes, the annual accumulated difference. That 21.6 minutes per year over 72 years gives you exactly 1 degree. So there you have it. That's the math of the precession of the equinoxes. Now, if we compare that to the math of the wobble, they're somehow exactly the same. Because they have to be. Just like it is photoshopped, because it has to be. Now the critical question. The wobble is a mechanical effect. Gravity acting on an oblate spheroid spinning in space, according to their model. The precession of the equinoxes is an observational mathematical artifact, the accumulated difference between two ways of measuring time and position. Sun versus stars. These are two completely separate things. One is a clock discrepancy, the other is a gravitational mechanical effect on physical mass. What are the odds that those two completely unrelated phenomena operate at the exact same rate? Not approximately the same. Not close enough that you'd round them together. Exactly the same. Precisely synchronized. And their model literally basically says they're the same thing, but they're not. Because if they weren't the same thing, seasons would drift. And they don't drift. In reality, if there was a genuine independent wobble, it would have its own rate based on the physics of the Earth's mass distribution and gravitational forces. And the precession of the equinoxes would have its own rate based on the orbital mechanics. And the sum of those two effects would produce the observational drift, and the seasons would shift accordingly, if it was actually real and not contrived and just inserted into the model. But that's not what they're claiming. They're claiming the wobble is the precession, that they're the same thing. One causes the other, which means the wobble rate was defined to match the observation. Not discovered to match it, defined to match it. That's not a mechanism. That's a patch, an ad hoc patch to save the model. They had an observation, the 20-minute annual gap accumulating over 25,920 years, and they needed something physical to explain why it doesn't destroy the calendar. So, what'd they do? They inserted the wobble, that by definition had to run at the same rate as the thing it was invented to explain. On a flat plane, none of this is necessary. The 20-minute gap accumulates. The stars shift slowly over time. The geometry is observer-centric. No wobble required. No perfect synchronized mechanical effect that just happens to match an unrelated astronomical observation. The wobble knows too much. It wobbles at exactly the right rate to cancel exactly the right drift to keep exactly the right seasons on exactly the right calendar dates. That's not physics. That's a model protecting itself.